Today we will be discussing the area of a triangle. So let's say you're given a triangle like this, ABC. Okay. So what is this area? That is the space that this triangle occupies on any surface. Okay. How do you prove this without knowing anything else about this triangle? So what's the best way to prove this? Okay. Let's think about that for a few minutes. Let's see. Okay, you are given this triangle here. Let's draw the triangle again. Okay. A, B, C. Okay, let's the length BC be small b, which we can call as the base. So BC is equal to small b is the base of the triangle. And let's draw a line from the point A perpendicular to BC, and let's call this D, and let that length be H. So AD is equal to H is equal to height. Height of the triangle. Okay. Now we can do one more thing. Let's change the color. So we can enclose this triangle into a rectangle. So let's draw a parallel line to BC, and let's join this together here. And let's say we join this here, and let's call this EF. Make it a straight line. Okay. So we see that the rectangle, the triangle ABC is enclosed in rectangle EFCB. Okay. Now rectangle EFCB. EFCB. We know that one of the sides of the rectangle is BC, which is the base of the triangle again, and we know that FC is equal to AD is equal to H because these two lines are parallel. So the distance between the two lines should be the same. So that way we can prove that the area of rectangle ECB is equal to one base BC into FC, which is B into H. Okay, that's the area of the rectangle. Now we can divide the bigger rectangle EFCB into two smaller rectangles again. Small EFCB, that's the bigger rectangle. We can divide it into two smaller rectangles. So let's say EADB, that's one rectangle, and then AFCD, that's the other rectangle. Okay, so we can say EFCB is equal to EADB plus AFCD. Okay. Now, as we can see that the line AB, if we take this rectangle EADB, the line AB is the diagonal of that rectangle. So that means that this area of this triangle EAB should be equal to the area of this triangle ADB. We know that when a diagonal divides the rectangle into two parts, the two parts should be equal. So that means that we can write it as EADB, we can write it as triangle EAB plus triangle ADB. Okay, that's one part. And the other piece is, let's look at this rectangle EFCD. Again, the area of this triangle should be equal to the same because the diagonal AC is the diagonal of that rectangle. So we can write it as ABC plus AFC. Now we know that EAB and ADB should be equal because it's the diagonal of the rectangle is dividing it into two triangles. So we can write it as 2 times ADB plus ADC and AFC should be equal for the same reasoning that the diagonal AC divides the rectangle into two parts, so we can write it as 2 ADC, which is 2 times ADB plus ADC. Now as you can see, like ADB, let's change the color a little bit and make it green. So we know that ADB, that triangle, and ACD or ADC, whichever way, is equal to our bigger triangle ABC. So that's 2 times ABC. Okay, now we know from earlier proof that area of EFCB is equal to B into H, which is here. So this is B into H. So the area of triangle ABC from this equation becomes B into H divided by 2, which is half base into height. That's the area of the triangle ABC. Without knowing anything about that, making some assumptions, we can easily prove that. Okay. Now let's take another example. We're given a triangle like this. Okay, ABC, where one of the angles is more than 90 degrees. So this angle is greater than 90 degrees. So it's called an obtuse angle triangle, where one of the angles is greater than 90 degrees. So this triangle is an obtuse triangle. Does this triangle also have the area half base into height? Is there a way to prove it? Think about that for a few minutes. You can pause the video and I'll give you the proof as to best way to solve this. Think about that. You can pause the video for a few minutes and think about that. But if you want to watch the proof, let's go ahead. Obtuse angle triangle. Okay. ABC. Okay. What we can do is, like, let's say you have let's keep this base fixed and let's rotate this triangle. So let's bring the point A here somewhere. Okay. So if you bring here A here, if you rotate that, so this becomes CA, and then this becomes B. So as you can see, this triangle is similar to the one that we just showed you, and you can construct your proof. So this becomes your base B, and then you can draw height H, and then you can do a rectangle enclosing the triangle and prove it. So irrespective of what shape the triangle is, the area of the triangle is half base into height, where B is the base of the triangle and H is the height. That's the distance from the upper vertex to the base, perpendicular distance. So that's the area of the triangle.